Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to discuss on the physical properties of the ionic substances and what are the learning objectives. The learning objectives are, it's very clear, be able to explain the physical properties of ionic compounds in terms of their bonding and structure. So there are a couple of properties which are very important. We need to talk about these ones. Ionic compounds typically have these common physical properties like the high melting temperature and boiling points, also the brittleness and poor electrical conductivity, and often soluble in water. So we are going to talk about these ones. So first of all, high melting temperature, we need to consider this in our mind. So can you please turn off your mic? I'm sharing the screen. Can you see it? Do you see this?
Yes.
Okay. So let me repeat it once again. Physical properties of the ionic compounds. We are looking onto these ones now. And those physical properties are high melting and boiling points, the brittleness, the poor electrical conductivity when the ionic substances are in the solid state, and often the last one is the often soluble in water. So high melting temperature, when we are talking about these ones, when we look into the lattices of the ionic compounds, we find that these lattices are strongly connected with each other because most of the ions are there present in it, the positive and the negative ions. And we know that there's a strong electrostatic force of attraction between these ions. Now, to break down this electrostatic force of attraction, a large amount of energy is needed, okay? And that large amount of energy needs a huge amount of temperature for that. So that's why the melting and the boiling points are rising, okay? Melting points and boiling points, they will rise due to these two factors, okay? Moving on to the second part, the brittleness. By brittleness, we mean to say when we apply certain pressure on the ionic substances, they started hammering, they started getting into shattered or into pieces. Now, if you look into this structure of sodium chloride, this structure is having the positive and the negative ions in it, okay? The red ones are the positive ions for sodium, and the green ones are the chloride ions. They're bigger in size. So when we apply pressure or we apply stress or we hammer it, the ions are disturbed actually. So the same charges, yani the positive and the positive, or you can say the negative and the negative, they get close to each other. Once they get close to each other, there's a repulsive force applied on them. And this repulsive force is rebouncing those particles back, and they're unable to stay on their original position. Rather, they break down into pieces of sodium and chloride, or small pieces, not even sodium and chloride, small pieces of the crystal. Electrical conductivity is the third important property. By electrical conductivity, whenever we want to talk about any of the solution and we talk about its electrical conductivity, we need to know that there must be ions which are carrying the charges, the positive and the negative charges. So if there are ions which are freely available in a solution, then we can talk about the electrical conductivity. Now, when we talk about sodium chloride or any of the ionic substances in solid state, the ions are stuck on their positions and they are unable to move, to break down, okay? But when you dissolve them into water, both the ions, the positive and the negative ions, they are free to move, okay? So when they're free to move, they are becoming good conductors at that particular time, okay? Any question? Okay. Talking about the solubility. Now, the solubility is a very important topic. I want you to please focus on this one, these structures. You can see this is a positive ion and this is a water molecule. Water molecule has two parts, the oxygen part which is negatively charged and the hydrogen part which is positively charged. The charges are partial ones, okay? Now you can see water is moving its partial negative part towards the positive ion. What about those partial positive charges? They will be towards the chloride. Okay, there will be chloride. There will be chloride. There will be chloride. So when we talk about solubility, we need to talk about two things in solubility. First of all, there is a solvent, okay, and there is a solute. The solvent particles, here in this case, water is the solvent, okay. The solvent particles are surrounding the solute particles, and you can see it here right in front of you. The solvent particles are surrounding the solute. You can see the solvent particles are surrounding the solute. Okay. Secondly, the positive and negative charges, the cation and anion, they were having a force of attraction. Now these water particles, they exert a pull, okay? They exert a pull and they separate the chloride from sodium, okay? So surround by the solution, by the solvent molecule, and then exertion of the pull is always there, okay? If we apply the enthalpies, which is in unit 2 mostly and in unit 4, then the concept will be a little bit complicated. So there's a word written called hydration of ions. What is this hydration of ion? Let me explain that to you now. When you dissolve a gaseous ion, Na gaseous state to Na aqueous state, this delta H is called hydration. Okay, so whenever there's a word coming hydration, it means that the gaseous ion has gone through an aqueous ion. That can be a negative ion as well, gaseous to aqueous. This is called hydration. Is there any question? So solubility of the ionic substances, when you dissolve them into water, water is actually working on these compounds. It's giving certain amount of energy to separate both the chloride and the sodium ions. If that amount of energy is enough for it, then the salt will be dissolved in it, and if it's not enough for it, the salt will not be dissolved in it. For example, sodium chloride is having a specific amount of enthalpy, which is 770 kilojoules per mole, okay, and water is providing around 777 kJ per mole energy. So this one is coming under this, so that's why sodium chloride can easily be dissolved in it. But when we take magnesium chloride, MgCl2, then there's a problem. Magnesium chloride has 2600 approximate energy enthalpy, okay, so water cannot provide that particular enthalpy, right? So that's why magnesium chloride is less soluble in water. The other thing is that if you want to explain solubility, the stronger the force of attraction between the positive and the negative ions, the more energy is needed to be provided to separate them, okay, even in dissolving them. So if the ionic substance force of attraction is depending upon, number one, the smaller radius of the ions. The smaller the radius, the stronger is the force of attraction. And number two, it depends on the size, the charge on the ion as well. So the cationic charge is +2 and the anionic charge is -2. The force of attraction is greater. It's difficult to be dissolved, right? Is there any question? Is there any question? Can you hear me? Where did I leave? You were with me in electrical conductivity, or you are not there with me in the conductivity?